Hello everyone! Do you want to see what's inside Ferrari shock absorbers? Then stay with us, because this is not a regular shock absorber. This is a magnetic ride system and everything inside is completely different. My name is Bogumil from AirTec and we specialize in professional suspension repair. By the way, these shock absorbers were sent to us from Finland, personally by John Haltunen. Do you know who he is? John is one of the best co-drivers in the world right now. Finnish, co-driver of Kalle Rovanperä, competing with Toyota Gazoo Racing and two-time world champion in VRC. Honestly, I'm very proud that we have clients like this, because when someone at this level trusts you, it means only one thing: you have to deliver perfect results. And of course, good luck in the next rallies, John. In this video, I will show you the full repair process of magnetic ride shock absorbers from Ferrari 458 Italia and how we bring them back to original OEM performance. Mr. Haltunen complains that his Ferrari feels too soft, unstable and floating on the road. Let's see how the shock absorbers behaves on the dyno. Before we start the actual test, I need to explain something important. Magnetic ride shock absorbers only generate damping force when electrical current is applied. If the car is turned off and there is no control, the shock absorber behaves almost like it has no damping force. To demonstrate this, we will first run a test without control. And as you can see, regardless of speed, the resistance is very low. It's almost zero, as if the shock absorber is completely empty. 10 kilograms in rebound or 20 inbound is nothing. Now, let's repeat the test, but this time with electrical control. Now we can see that the shock absorber is working and is much stiffer. Unfortunately, this is the maximum stiffness that the damper can achieve. Looking at these results, we can clearly conclude that Mr. Haltunen is absolutely right. These shock absorbers are too soft for this Ferrari. Now let's open them and see why. Here you can see the oil from the shock absorber. It's like a foam. There is bubbles inside. There is gas inside the oil. The oil is not consistent. It's foamed. As you can see here, the oil has turned into a foam. This happens when gas mixes with the oil. Very important to clarify. This is not the reason why the shock absorber feels soft. The softness comes from fluid loss. The gas inside the oil causes something different. It leads to improper operation. The oil starts cavitate, the damping becomes inconsistent and the shock absorber loses control and stability. So even if the shock absorber is not completely soft, it will never work correctly in this condition. Now, the question is, what caused this? The problem comes from the separator. This is a monotube shock absorbers. It means that the oil and the gas are separated by these internal pistons, the separator. Its job is simple, to keep the gas and the oil completely separated while compensating for volume changes when the piston rod moves. But over the time, the O-ring on the separators wears out, and this happens because the magnetic ride oil is slightly abrasive. Once the seal is worn, gas starts leaking into the oil, and this is exactly what we saw. Now, let me show you our solution. We install an upgraded guide system. Our modification, the shock absorbers becomes fully serviceable. It can be disassembled and rebuilt in the future, just like a proper racing shock. The guide itself is also serviceable, which means we can replace only the oil seal when needed, without rebuilding the entire unit. At the same time, we use much better dust cover, which protects the oil seal and increase its lifespan. And of course, we use original magnetic fluid from Lord. This is magnetic ride fluid. No alternatives. This is the only way to guarantee correct behavior, correct response, and true OEM performance. The way this oil works is very interesting. Here you can see amount of oil on transparent surface. When we apply a magnetic field, you can see how the oil reacts and becomes thicker. When we reduce the magnetic field, the oil becomes fluid again. The same process happens inside the shock absorber. This is the working piston. The working piston is actually an electromagnet. The vehicle controls the strength of this electromagnet, which changes the viscosity of the magnetic oil. This allows the shock absorber to change its stiffness instantly. Before the final test, let me show you how we restore the exterior. This is an old shock absorber, so we refinish it completely. Here you can see the blasting process and how we remove the old paint using glass beads. So the goal is to restore the surface properly so we can protect it as the best as possible against corrosion. Now let's take a look at the dyno results after the repair. As you can see from the graph, the shock absorber is now working properly. The damping force is higher and, more important, stable and consistent. Before the repair, the maximum force was around 160 kilograms, and now we are reaching 200 or even 210 kilos. That is an increase of around 25%, which is exactly what this car needed. The damper is now stronger, more controlled, and able to properly stabilize the car. Now, one very important thing, these shock absorbers cannot be revalved. The stiffness in a magnetic ride system is determined only by two things: First, the strength of the electromagnet, and second, the type of the fluid inside. This is something we cannot change mechanically, like in a traditional shock absorber. There are three types of original Lord magnetic ride fluid. The first is MRF 122, second MRF 130, and last MRF 140. They differ in viscosity and in the concentration of magnetic particles. And this is the maximum we can achieve with this Ferrari. Everything is now restored to a proper working condition and performing as it should, as original OEM. We truly hope that John will feel the difference once these shock absorbers are back on the car, because in the end that's what matters most. This is how it should feel. OEM performance, no compromise, AirTec. Thank you for watching.